What's up, everybody? Welcome back to the channel. Josh Helm here with Texas Best Construction, and today we're bringing you some new innovation that's happening here in the Dripping Springs, Texas.
Yep, just outside of Austin.
Just outside of Austin. I'm here with my friend Trent Depth with Timber Builders, and he's here doing a project with Risinger Build, which is always cool to be out on a Risinger Build project. And Trent, man, you guys are, what are we doing here, buddy? We've got
We're building something big out of wood.
Cranes.
I know that's odd for you. You know, you're all about the steel buildings. I get it.
Come
but
on,
this
man.
one's all wood. It's all wood.
I know. Where's the steel? Where's the welding guys?
Yeah.
Where's
No
all this
steel,
stuff?
no welding, no smoke.
One of the things we're here learning today about is some different versatility, some different tools to have in your toolbox. And I am enjoying being here and looking at this product. But just to kind of give you guys a rundown, this is what they're calling and coined the Mass Ply Light, where it's basically like mass timber, where you're able to span with LVL approved type materials, right?
Yeah.
Give us a rundown collectively of what this is.
Well, this is mass ply,
Yeah.
and so that's a type of mass timber, and it's made by the Frères Lumber Company up in Lyons, Oregon.
Okay.
And so they make a variety of sizes of materials, everything from 1.5 inch now all the way up to 24-inch thick slabs of wood that are 8 foot wide by 60 foot long.
Holy cow.
I'm telling you. And out of those billets, they can make columns, they can make panels, they can make beams. And so what we've done is we've really shrunk a lot of those elements down that would be usually used in a much larger building and applied that to residential construction in a similar way to how you'd build a post frame house, which is where I got my start, was with post frame.
And so a lot, and to me, it's like there's a lot of similarities between what we do, although with the steel, I have a little bit wider spanning when it comes to my post or my steel columns. And now here, we're going more of about an 8 to 10 foot on the main post.
For the grid, yeah.
For your columns, and which is similar to what is in post frame. Actually, these walls look really similar. I guess the only thing difference between here and post frame is you got like this 1.5 inch thick
Panel instead of the girt.
plywood wall.
So, I mean, technically, this is a post frame structure because of the way that it's built. The gravity, the gravity loads are carried in the columns or posts, and then the lateral loads are carried in the panels.
Yeah.
In a post frame, it normally would be girts.
Yeah.
You know, girts that are then sheathed with some sort of OSB.
Well, let's show them a little bit,
Yeah,
so
come on.
we can give you guys an example of what's going on here.
So this is the exterior. What you're seeing here is our WRB. We used Delta Vent SA from Dorkin.
Yes.
And you know, we have a buck, and this is where the windows go in, but everything is LVL behind this. Even our rain screen is LVL. And you know, because of the way that it's positioned, it allows water to drain off, and it holds the insulation in. It serves several different purposes.
There's really some neat, I think, wall details that you guys are using here. Of course, in collaboration with Risinger Build. Always great flashing details. So if you guys are looking for that kind of information, you can always find that. But here with the Dorkin product, this Delta, this is really cool.
Yeah, it
like
seals off the wall from all the water and air, but then it allows vapor to come through. It's vapor permeable.
And it's self-adhering.
It's peel and stick.
So, which is
The
pretty
really
cool.
neat feature is this strip here, where it's peel and stick on both sides of the membrane. So when you come down and shingle over it, it actually sticks to the surface. So I'm a real fan of the Delta.
And one of the things we're achieving here is all of this insulation, which early on in the project is kind of interesting because this has got rock wool insulation, which this is the Comfort Board 110 on the exterior. And now some of this is going to continue, all of this is going to continue with this later. But one of the things that's unique about what they're doing here is all of this is getting assembled on the ground.
Let's go look at it.
Let's go show them a little bit of what's going on here.
So, you know, one of the reasons that we do it on the ground is because we're taking what normally would have taken days and converting that to hours. By building it on the ground, like right now what you see them doing is we're flashing the windows and installing the windows on the ground.
Yeah.
And this would take an entire day to just install these windows, or maybe half a day. But now what we've done is we've been able to reduce this down to a matter of hours, and then we fly this entire wall panel up. And this wall panel here is, let's see, this one is 30 by 23 feet. So
Very
it's
cool.
a big panel. It'll weigh about 9,000 pounds. But, so a lot of people say, well, that's just like SIPs. The big difference is SIPs takes a factory and you have to ship it on a truck. And, there's a big lead time. And once you've built that panel, there's no changing everything.
Yeah, and how are you going to get a 30-foot wall on the truck?
No,
right?
yeah, you
It's
won't.
Not happening.
So, we broke the exterior of this house down to 22 panels.
Okay.
And then we're able to build it very rapidly. The interior is built similarly, but a little bit different. It's not built in panels. We do it more what we call platform construction, where we put the columns up and then beams and then whatever our cladding on the top of that is, the decking. But yeah, this is going to go up super fast. They're almost about to install. Well, you can see they're installing one of the 6x6 windows.
We got windows being installed today. We got walls being installed today.
yeah.
We got insulation being installed today.
And some of these windows are tall. And I was talking to you, a lot of times on your builds, you have windows that are up really high. And installing one of these big windows on a man lift is not necessarily a fun time.
Well, and yeah, the more maneuverability you got, the potential for something getting broke, and nobody needs that to happen, because then it's reordering or getting it fixed.
And there's a lead time on windows. I didn't know if you knew that or not, but
I mean, yeah, I figured it out.
Yeah.
Especially a few years ago, we started having a lot of trouble with windows. But I think the versatility of what we're talking about here, fits really well in our Barndominium world, where we're already building like our main frames on the ground.
Yeah.
Stand them up. But the attractiveness it keeps going, because it's not just here. It's not just the wall systems. It's the roof systems as well.
the nice thing about these panels is once they're up, they're ready for siding.
Yeah.
So they're immediately, that's what one looks like when it's up. So that's ready to have the siding put on, and we have a little bit of detail to work to do on the next wall that attaches to it. But
and these walls, I was looking at a really tall wall over here, and we could show you guys here in a minute, but there's hardly any budging of these walls.
Very solid.
Tell me about the anchoring systems and show us what we're using here.
So we'll take a look at where it starts. So it starts at the sill, and
I guess we should tell them what kind of seal and what you're doing here.
Yeah, it's an LVL sill. It's not treated, and I know there's going to be a lot of people asking about that. We have a capillary break with a really good sill detail on the bottom, so we don't have to worry about any rot or damage to the sill. And it's LVL, so it's already very resistant to water damage or any of that, because it's so compact. So we anchor that down with the Simpson Strong Tie Titans, and then Simpson Strong Tie makes a hold down, and this is an in-bed all thread.
We've got one over here. We could show them the connection.
So that in-bed all thread inserts over the hold down, and that hold down is put under tension. And it's kind of like the analogy I like to use is it's kind of like those toys that you had when you were a kid, that you pull the string tight and it's upright, and then you loosen it up and it flops over.
Yeah.
Well, we've pulled that string tight. And so it's putting this post under tension, and then on the other side we have an angle bracket to work on any lateral movement. So Simpson makes some really great products, and one of our big goals on this was to not have a lot of custom connectors, custom fittings. Everything here is stuff that you can order from Simpson or one of the big box stores very easily and have in your hands in a matter of days.
23-foot tall wall.
So that'll be the vaulted height of the ceiling here.
And you're seeing the inside frame here, but I mean, even though these are here,
they're not under tension.
There's no tension here, and this is just super tight. So when it comes to engineering strength, tell us about the modeling for engineering.
Well, so we put together the geometry model and then send that off to our engineers. at Aspect in British Columbia. They only do mass timber, and they helped us come up with a lot of the innovations. You know, so these aren't all our original ideas. You know, we have a real holistic approach to building. So we pull from, you know, we find people who are experts in an area, and we give them our ideas, and then sort of let them come up with things. In fact, they came up with this. You know, what the big difference between a post frame structure and this is, normally you see one of those big brackets that, you know, has the through bolts and all of that.
Yeah, I'm familiar with
So we wanted to find something that was a little bit more elegant and a little bit more simplistic that we could use with standardized
So if we're going for aesthetics here?
No. It is elegant, but you know, something that was easier to source.
Yeah,
you know, anybody who's tried to source those post bases, especially in the South, they're not at the local big box store.
Yeah.
You usually have to order them in, and you usually have to order a large quantity of them as well. So
can we?
This is something you can go to the local big box store and order if it's not in stock already. That's a hold down.
And so it doesn't stop here, but you know, we've got more anchors here.
Yep.
But what is the method for installing these, and
So
at what point do you do it?
After the slab is poured, we like to put our anchors in after the fact.
Okay.
So these anchors are the Titan HDs. So we pre-drill a hole.
These right here.
Yep. We pre-drill a hole into the concrete down 6 inches.
Is this one of them?
Yep, that's one of them right there. And then this gets sunk in.
Okay.
And then that adds compression along with the square washer. And then on those, we pre-drill the hole, and then we epoxy fit the all thread into the ground, and then it sets for 2 days, it cures. And then once that's rock solid, then when we go to install the wall, it just slips down over it, and then we tighten it to tension.
Nice. Well, I mean, it is rock solid. I'm just telling you guys, we do 2x6 studded walls, and if I didn't have that tied off to something, I mean, I definitely could see there being a problem with that.
Yeah, and a lot of the reason we even use the brace is to get it true off the crane.
Sure,
is to plumb it.
Yeah.
You know, once it's plumbed, the brace is there sort of as a belt and suspenders just in case we get a really big wind. But I haven't even seen these walls move in the big
Now,
winds.
you guys are using a crane for this project, but this is a specialty top project. Can you tell me a little bit about this project?
We're using a crane for this project because we cut it into the side of a hill, and that hill just happened to be made out of limestone.
Yeah.
So, you know, typically this is a building that could be, you know, constructed with a telehandler, you know, a 10K telehandler. We might need to work on the size of our wall panels, so we're taking advantage of the fact we have a crane.
Right.
But, you know, all of this is done similarly to how people have seen post frame walls get put up, you know, except for it's not so much a tilt as it is a lift and a set.
Yeah.
So.
Well, it's very, very cool. And I mean, what room are we standing in here? This is
the den, and I was really excited. So we actually helped design this house with the owners, and one of our things was we don't want a man cave, we don't want a game room, we want a den.
Yeah.
So the walls are going to be mahogany. There's going to be a bar. There's a safe in the corner that's behind a hidden door. There's an office. This is kind of the owner's retreat.
I got you.
He's going to play pool. He's got a pool table.
And it's open.
And it's open. It has a whole mezzanine here that'll be accessed. We're going to build a beautiful spiral staircase right here, all out of the LVL material. And then there'll be a library up there where you can sit and relax. And
so a lot of people that's been following this along, and we'll start walking this way a little bit, these guys are about to finish up with this wall, so we're going to see it fly, hopefully.
And it's going to go in this space right here.
Yeah, this wall is about to come into this space.
And it looks so much bigger when you look up and you're seeing how tall that wall is than it does when it's on the ground.
Oh, I understand that, actually, because when we put our steel on the ground, it's one thing, but when
you're like, that's not that tall.
Yeah, and then it's like, oh my gosh, it's a huge building.
Oh, yeah.
But so in this room, what is this going to be?
This is the kitchen, and then there's a living room in this area. It's a great room.
Now,
and it's very great because it's 23-foot vaulted ceilings.
It just looks like there's a bunch of plywood everywhere. Can you explain about the finishing detail?
Yeah, so the plywood is the substrate that we're going to be applying a 1/4-inch veneer to. So
on your interior walls. So let's show them some interior walls.
Yeah. So on top of this, we'll be applying in this room. It'll be horizontal strips, so it'll have kind of like a lapboard look. But we're only going to be using 1/4 inch, in this case birch, that'll be whitewashed, and it's a birch plywood. So it's a hardwood and it has a beautiful look, but it's not a super expensive finish. And we'll apply that to the entire wall. And there'll be about 1/8 of an inch reveal in between each board.
Cool, so almost like a shiplap look in here. So on our exterior wall, so you're already achieving all of your insulation on the outside. So this leaves all this open for the inside. I think this is a new way for some folks to imagine construction.
Yeah.
Because I mean, although it's not a new thing to do exterior insulation,
Right.
but you guys are using the rock wool on the outside, and you're achieving all the insulation requirements out there before it gets into here. What makes this so? I mean, this is 1.5 inches thick here. Then you have a 5-inch column, which is similar kind of to our 5.5 inch.
Yep.
But in our cases, we would be spray foaming all this, right?
Right.
Well, that's not needed. Leaves all this open. You could pretty much run anything.
Run your wire, run your pipe, run a whole variety of low voltage things.
Yeah.
Or you can surface mount all that, and have this be your finish, where you put your finish surface.
Even your window bucks are 1.5 inches. So it's consistent, as well as the ones that go out. But here, this is the way you're framing this out. What are these for? Just to help brace off?
These are just so when you take a look at the window buck, really the only thing that has to be there is the window buck.
Yeah.
None of this serves any structural purpose.
Yeah.
So all this is a nailer.
Gotcha.
So the biggest reason we continue this all the way to the side is so that it's a spacer when we're building the walls on the bottom. So it has more to do with the constructability than the structure. So that's why these are only 3 inches wide. They're very strong, like you can't move them, but there's no actual structure to it. They only have a single screw on either side.
Yeah, it just gets toe-nailed, right?
Yeah, I mean, you can move them around, but they're very,
This one, not so much.
Yeah. But that's to nail our cladding on the inside and the finished wall. There's not going to be any drywall in the building.
No drywall. So that's a new one for a lot of you that may be watching this. No drywall. It's going to have more of, I don't know, some people would say, what do you think the look this is going to be when it's
they're
done?
going for more of a modern look, like a modern farmhouse look.
Gotcha.
So not so much on the rustic side,
Yeah.
because it's going to be birch.
Could certainly,
in the patterns
you could
and
certainly go rustic, right?
It could.
Yeah.
It could go rustic. It can go modern. You can even have the look of drywall. If you fill the seams here very quickly and do a quick sand, and then apply a drywall like a knockdown texture or an eggshell, and then paint it, it'll look just like drywall.
And it doesn't mean that you can't have drywall, because you could certainly easily put drywall.
Put drywall right on this,
here.
just as easy.
It just means that you have the versatility with the spanning, where on some of these walls you're putting another layer of the 1.5 inches. Where is that happening?
All the interior walls, like this wall over here.
Yeah.
This is an interior wall, so there'll be 1.5 inches on both sides. And one of the reasons that we did that instead of just a solid panel in between the rooms was so that the plumbers and electricians had somewhere to run their stuff.
Yeah.
Everybody's used to having that cavity in between the two rooms to be able to run electrical, plumbing, some HVAC type of controls. But that gives us that cavity, and we utilize that space.
Structurally wise, you don't need any of that. You could have just
really
one side and achieve walls. Now, for somebody who wants to imagine maybe even a more open concept, you could say, hey, this is going to be my finished wall.
Yes.
That would be definitely, somebody who's got that kind of imagination or wants to do something a little bit different or a lot of bit different than what we're accustomed to seeing.
Yeah, it gives you a lot of versatility. So you can either go and finish it to look just like a normal house.
But I think the reason why a lot of people don't consider doing that is because you're going to have insulation, and here you're not. So it's like it's very smart. I like the versatility of the materials because it means no matter what type of consumer you are, you might be able to do that as well. Now, a lot of our people are big on cost, which we don't normally have all that information either. But how is this comparable to some of our typical construction?
Well, every house is different, but in the pricing for this house, if you were to compare it to this house built out of a stick frame structure, it's very comparable. It's almost a wash. In some respects, depending on how you'd finish the walls out. So, we were talking earlier about like a level 5 drywall finish. It'll be less than that.
Right.
So in general, if you take a look at the cost of what a normal stick framed house would be, it is at or below that cost. Now, there's things that go into that. There's the planning phase. There's the efficiency of the building. If you don't plan it out right and it takes you twice as long to build, well, then it's the same thing with stick though. If it takes you twice as long to build a stick frame, it's going to be more expensive. So, the biggest difference between this construction method and stick framing is the front loaded planning is larger and the build time is shorter.
Okay.
So, you have more planning, but the delivery on the structure is shorter. So altogether, it's a shorter time frame, even though it appears that it's longer because you have a lot more planning up front.
A lot more planning, and that's I think always important because when you're out on the job, you're spending a lot of money when it comes to on the job.
On the job is very expensive.
Yeah, very expensive on the job. Of course, pre-planning can be very expensive as well. But some of the planning that you guys had involved on this project had to do with kind of chartering some new territory, which takes a little bit more time. And so
a lot of little problems to solve.
Yeah, a lot of little problems. And so I'm asking these questions too because every little change, right, it kind of changes the flow. So you're trying to imagine a new world of operation and in every system that it involves, which is pretty cool. It's really neat to be at a project like this because it does open your mind to imagine something a little bit different way. The 1.5 inch thick walls.
It's ridiculous, I know.
It's crazy.
But it's especially if you're used to seeing 7/16
right.
or even 5/8, and you see a lot of it.
Right.
The biggest thing for me that I had to get used to is when we're moving our little cutoff scraps, and I look at a piece and I'm like, I can get that. And you go to pick it up and you're like, maybe I can't. I need help. And you're like, I can't believe I'm getting help with a 5-foot piece of wood. But
But let's talk about that for a second because you have a little bit less waste involved using this material. Why is that?
Because of the pre-planning. Okay. So we do all of this has been modeled out in our CAD program. So we use Rhino, and we have a designer on site, and so the entire build is modeled out in there, and we have everything modeled down to every screw that goes in. There's no nails in this house, so we use all screws, but there's a lot less screws than there would be if we did use nails.
Yeah.
So some of the efficiencies are when we're doing our screw order or our connector order, we know exactly how many we need. We always order a little bit of extra just in case, but what we're finding is we're spot on with exactly what we need because we knew what we needed before we even started building.
Yeah.
It's the same with the flashing. It's the same with the weather, the WRB.
Yeah.
We knew exactly how much we were going to need, and so we knew exactly how much to order. So you don't see a lot of waste. And then with the wood, we've already planned all of this out. So if there is a panel that is 16 foot long for one area, we know that a portion of that cutoff goes to another area.
Yeah.
So we've done a lot of work in making sure that we've optimized our panels as well.
Awesome. And so we're replacing our 2x6s, 2x4s. We're replacing that with the LVL like Mass Ply Light system. but we're also replacing our ceiling joists and things like that. Let's go show them a little bit of ceiling so we can see what that looks like.
Okay, so we're here in what is going to be the master bath, and you'll see what pretty much looks like normal joists, 24 inches on center. The big difference is these joists are 32 foot long, so you get a lot less vibration. You know, everything's connected together. But the real takeaway from this is we don't need this many joists. We have this many joists because we're putting a ceiling on this.
Gotcha.
We really only need a joist every 6 feet.
Because the deck runs this way.
Because the deck runs that way and it's 1.5 inches thick.
And the deck is the same product we're using on the walls.
Yeah, so what's above us here is actually just a mechanical room, but it's the most sturdy mechanical room you'll ever see, you know, and they're going to use it for storage and things like that. But because the LVL panels are so strong and they have the ability to span more than, you know, a normal 5/8 inch.
So what is this, an 8-inch, 10-inch? What is this?
These are 8-inch.
8 inches. So what is the spanability on? You know, is it typical to? It's going to be kind of typical to what we normally would do, right?
It's a little bit more than a normal 2x8.
A little bit more.
Yeah, a little bit more than a normal 2x8 because it is LVL.
Yeah.
So
that's right.
you know, when you're going into your normal house and you're looking to do big spans, that's generally what you would go to first, or steel for like a header. So it's probably about, and don't quote me, but it's you know, because it's not like we're on video.
Yeah. Maybe just a general.
Yeah, it's probably like 20 to 30% more span.
I was just curious.
But in general, they're stronger, so you've got less flex, you know, and less deflection of the member. So we're in general using it in the same spans that we would use a 2x8, except this doesn't flex as much. So you know, when you stand on it and give it load, it doesn't deflect.
And look at the detail here, guys. You can kind of see how they were able to do this ceiling joists. So you've got your frame wall. They were able to use the ply, this Mass Ply LVL across here and attach that in. They've got the blocking underneath that, but it has an opening between the wall, which gives you still the versatility for passage, and you've got the support here where these 8-inch joists can sit on top of. I mean, I'm just seeing all this and it's like, it's way more open. Like if somebody didn't have exterior insulation, like you could insulate
this would all be filled in.
All that.
And you can still add that.
Yeah.
You know, so right now this house sits at like an R19.
Okay.
And I know we've talked about how R value is very deceiving. It's actually greater than that, because if I were to build a normal house with studs and put insulation in between those and the same amount of insulation, that would also be an R19, even though each one of those studs is a thermal conduit to the outside.
Right.
So it's greater than an R19. It has a higher effective R value, but basically what we're saying is it's an R19.
Because the mass of this too gives us insulation.
And it's all sealed.
Which is a little different than, like, say, steel or metal, because it's more conductive, right?
Yeah, it's not a lot of R value that the wood has, but it does have some.
Yeah.
It's like 1 or 2 R, you know. But
which is really cool.
Yeah, so we have our ledger there, and then on the other side we use a beam.
Okay.
So the rest of this area is built with columns and beams.
So the beam goes across. We've just got one big wall here, which is, you know,
cavity.
It's going to get a door here. Of course, you'll have another run of this on this other side.
Yeah, we'll have another run of this on this side. This is a little bit loosey-goosey right now, but there's a door frame that gets built out here, and then that stiffens it all up.
Yeah, certainly. But, I mean, even that I can feel. I mean, can you imagine just having...
You're not running through that wall.
If I just had a sheet of plywood here, what it would be doing.
Oh yeah.
You know, it's just nuts. And here's
don't
here's
try
some of
lifting
that.
it.
I'm not going to try to lift that up. Look at this. This is what we're looking at. This is what we're looking at.
So this one sheet weighs about 1.5 times like a normal 4x8 would.
I mean, that is just solid. So this is our roof deck, this is our wall deck, this is our interior walls. This makes up our joists.
This is the doors. So we're making all the interior doors out of 2-inch LVL. So, and then those are going to be flush mounted, and you're going to see the same wall paneling on those as you do for the wall. So they'll kind of just blend right into the wall except for the handle.
Very, very cool. I mean, guys, you tell us what you think in the comments. This is a pretty interesting exhibition of what I'm seeing here. I mean, I'm really impressed. Now, tell us about some of these kickers or these nailers. What are these for?
That's just to attach the paneling to.
The veneer?
So on the exterior walls, we'll actually be using a 1/2-inch birch. And so that 1/2-inch birch will go in a pattern. In this room, it's going to be a board and batten. So we'll have 12-inch boards with battens.
So in the case where you're using the board and batten, you're using a birch, a 1/2-inch.
1/2-inch birch.
So you're covering all this.
It's a 1/2-inch birch plywood.
Plywood, yeah.
Sort of sticking with the theme here.
Yeah, keep with the ply.
But it's a hardwood and it looks great.
Yeah.
And it's really strong, and it's going to give a very modern, bright look to the room because it's a lighter wood.
And ultimately,
whitewash
you're just doing that here because you needed something to nail to, right? And it gets.
That's all these are.
And if you put the 1.5 inch here, and then you put all that, you're losing some space, and you don't need it for your structure.
Correct.
Is that the reason? Okay. Oh man, Trent, this is amazing. Well, guys, I hope you're enjoying the tour here for this Mass Ply Light timber builder, Trent Depp and Risinger Build working together on this project. We're looking forward to coming back when you guys get some of this.
We're flying in some of the beams.
Roof system, and because I'm really interested.
It's going to be soon.
Yeah, I'm really.
It goes quick.
Yeah, he's telling me it's going to be like maybe
next week.
Next week. I'm really interested in coming back and seeing that. Put some comments below. Let us know if you guys would like to see that on this channel. Otherwise, I'm going to come see it anyways. But if you guys don't appreciate this enough, maybe we're not going to share it. No, just kidding. We appreciate you guys following along. Give Trent and Timber Builder some love. Give Risinger Build some love. Let them know what you think about this stuff and what you're imagining on your end. We think this is pretty sweet. And Trent, man, congratulations on this project.
Thank you.
You guys are doing an awesome, phenomenal
We'll be doing one
job.
for you soon enough.
Yeah, yeah, we're looking forward to it. Guys, I'm Josh Helm. This is Trent Depp with Timber Builder. I'm wishing you all the best. Thanks for watching. Texas Best.